The data in the table below are smiling times in seconds of an 8-week-old baby. All right, so what we're looking at is a frequency distribution. All right, these are the individual class ranges. All right, so the first class range has a lower class limit of 0.7 and upper class limit of 5.2. And if you'll notice, this next class starts at 5.2, but there's this notation here and here, okay? In interval set theory and mathematics, if you use a bracket, which is this one right here, you're including the value. If you end or start an interval with a parentheses, you're not including the value. So 5.2 is actually only included in the first group here. It starts at whatever number is right after 5.2. All right, but ultimately this is a continuous distribution. All right. Now, it's a continuous distribution, but we're looking at it with frequencies. That's okay. All of these frequencies are about the same. I would say the best statement here is that this is a uniform distribution. All right, it certainly isn't skewed in any way. Mound-shaped, same thing as bell-shaped. Definitely isn't bell-shaped. Well, it is symmetric, but it's definitely not bell-shaped. Bimodal, it doesn't have two peaks. All right, I get it. These two values are, higher than the rest, but they're not higher by that much. It's not really enough to say that this is bimodal data. How many babies were used in this sample? All right, so the number of babies included in the sample is going to be the sum of the frequencies here. So I'll just use a calculator real quick, and it is 11 times 3 plus 12 times 2. So 57. To 2 decimal places, what is the relative frequency for the category 14.2 to 18.7? So that's this category right here. Relative frequency, if you will recall, is kind of like the percent of data contained within that particular class range. So we have 11 items in that particular class range out of the 57 total. So 11 out of 57, that's going to be 0.193. Or I guess it said 2 decimal places, so 0.19. All right, which bar would contain the median? Okay, well, to find which one contains the median, here's the thing. So if we actually listed out what these individual data values were and had a list of them sorted, we could find the median. But the median is the middle value. So here's the thing. There's 57 items. The middle value is going to be at the 57 divided by 2 position. So 57 divided by 2 is like the 28.5 position. So if I had a list of all of my data, whichever value is at the 28.5 position, that's what I would be looking for. So somewhere between the 28th and the 29th position. Okay, well, I don't have a list, but I know the first 11 values are in this range. Then the next 12, which would be a total of 23 values, would be up to this range. All right, so then the next 12, which would take me up to 35. All right, so this would be the 35th value, basically. This would be the 23rd value. So that means the 28.5 value is somewhere inside this range right here. So I'm looking at 9.7 to 14.2. And that's that one right there.